Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 10, Unknown Length and Area Problems. Okay, classwork opening exercise says, in the following figure, a cylinder is carved out from within another cylinder of the same height. So these two H's are equal. The bases of both cylinders share the same center. A, sketch a cross-section of the figure parallel to the base. Okay, so this is what the cross-section would look like. So if you cut it, what they're saying was cut it straight across horizontally with the base parallel to the base, then this is what it would look like. Or if you were thinking about looking straight down from above, that's what a horizontal slice would look like. So you have the outside edge. This piece is all solid, and then this is the hollowed out center. So it is like a ring looking at it from above. B says, mark and label the shorter of the two radii as R and the longer of the two radii as S. Okay, so the first thing I want to do in that situation is, first of all, we want to have a point pretty close to the center. Let me try that again. I'd say like right there. Okay, there's my center. So then if I drew a radius, now let me do my straight segment. Obviously, you're going to use a ruler. Okay, but with my program, I don't need a ruler. All I need to do is this. All right, so if I drew a radius, that's the radius of from center to the outside edge. And then I'll do a, whoops, I shouldn't have done that. I will draw another radius. Let's use a different color for this one. And I will go over here. Okay, so it almost looks like a clock. It's 10 after 4. No, it's not. Okay, so anyhow, the outside radius, it says mark and label the shorter of the two radii as R. So this is R. And the longer of the two radii as S. So the red one is S. Okay, that was easy. Now it says show how to calculate the area of the shaded region and explain the parts of the expression. Okay, so I wanted to shade that for you. So here it is. And we want to calculate the area of the shaded region, show how to. We don't have any values, but we can come up with a formula, and that's what they're asking us to do. So the area of a circle equals pi r squared, where r is our radius, of course. But we have two circles here. So if we take the area of the outside circle, but we cut out the center, well, cutting out the center is like subtracting it out. So we want to take the area of the whole circle and subtract the area of the inside circle. So the area of the ring is going to equal area of the outside circle, and the radius of the outside circle is S. So the area equals pi S squared. Okay, that's the outside circle, minus the area of the inside circle, which is pi r squared. And as you can see, we can simplify this because we have a common term in each. We can factor out a pi value. So the area of the shaded pink region would be area equals pi times the quantity S squared minus R squared. So there's the formula for the area of that pink region. Okay. Number 1 exercise, it says find the area of the following annulus. Okay, so that's what they call that, an annulus. All right, so there's the outside, there's the inside. So now that I've got this equation, write it a few times to remember it. Area of the annulus would be pi times outside radius minus inside radius, both squared. Substitute in your givens. Okay, now remember R is the smaller one. I think I have that backwards. No, that's right. I just reversed this here. Okay, I was looking up here saying that's right, but no, it's this one that I did wrong. area equals pi times s squared minus r squared, where s is the larger radius and r is the smaller. Okay, sorry about that. So now substituting in the givens, and then I wrote this in the wrong place. That should be there. Substituting in the givens, s squared, s is the outside one, that's 9, 9 squared, minus r squared, which is 7.5 squared. Okay, so therefore the area equals pi times 81 minus and 7.5 squared is 56.25. All right, so in my calculator, I have 56.25. I'm going to subtract 81, and you're going to say you're doing it backwards. Yes, I am, and I get a negative 24.75. Then if I multiply that by negative 1, or just ignored that, then that is 81 minus 56.25. So my area is going to be 24.75 pi. Okay. All right, so it did not say to round to the nearest tenth, hundredth, whatever. So I'm going to leave it in terms of pi, but we don't know that it's inches or centimeters or meters or feet. So we just put units. So it is units and it's area. So it's units squared. Okay, page 2 brings us to exercise 2. So let's try doing this without a diagram this time. Okay, we all know what an annulus is now. There's a picture of one here, but that's what we're talking about. It says the larger circle of an annulus has a diameter of 10 centimeters. So right there. So I'm going to call my larger radius capital R, and a radius is half the diameter. So the larger circle has a radius of 5. And the smaller circle has a diameter of 7.6 centimeters. So therefore a radius of little r for the smaller circle, smaller radius, of half of 7.6, which is 3.8 centimeters. What is the area of the annulus? Okay, so area equals, so it's area of the annulus or the shaded region. So the area of the shaded region equals pi times big R squared minus little r squared. Okay, so write the formula, substitute in the givens. Like so, simplify. And let me get my calculator. So 3.8 squared equals 14.44. So therefore, the area of the shaded region equals, and if I take that 25 minus my answer of 14.44, I get 10.56. So it'd be 10.56 pi centimeters squared because it's area. Okay, so that's number 2. Number 3, in the following annulus, the radius of the larger circle is twice the radius of the smaller circle. So 2r equals big R. If the area of the following annulus is 12 pi units squared, what is the radius of the larger circle? So let me highlight some things here. Okay, radius of the larger circle, twice the radius of the smaller circle. And the area is 12.5 pi. And then what are we asking for? What is the radius of the larger circle? Okay, so now we're going to do this. And as I always say, write a formula. So area equals pi big R squared minus little r squared. So there's my formula. Substitute in the givens. Okay, 12 pi units squared is my area. So I'm going to put 12 pi. I'm going to just ignore the units for right now. 12 pi equals pi times, and if big R is 2R, then that would be 2R quantities squared, okay, minus R squared. In simplifying that, I get 12 pi equals pi times, and then 2 times 2 squared is 4. R squared is R squared minus R squared. Okay, and then simplify some more. 12 pi equals pi, and 4R squared minus 1R squared is 3R squared. Okay, so we have a pi on both sides. So if we divide both sides by pi, those would cancel. And I can divide a 3 out, and that would make this 4 equals R squared. Take the square root of both sides, and we get R equals the square root of 4, which is 2. And we're calling them units. So it's 2 units. The radius is 2 units, so this is 4 units, 2R. Okay, number 4, an ice cream shop wants to design a super straw to serve with its extra thick milkshakes. Okay, that is double. That is, I tried to do my highlighter here. That is double both the width and thickness of the standard straw. And the standard straw is 4.4 meters in diameter and 5.5 millimeter thick. 4 millimeters in diameter, 0.5 millimeter thick. What is the cross section parallel to the base area of the new straw? Round your answer to the nearest hundredth. Okay, so let me draw this. Okay, so this would be a cross section of the straw, the regular straw. So now we're going to design so that it's double both the width and the thickness. So let me make another. Okay, so here is our straw and our super straw. So now let me just draw a line segment, a diameter, if you will, all the way through both. Okay, so there's our diameters. Okay, now let's label these up. Choose blue. Okay, so let's see. A standard straw is 4 millimeters in diameter. So this whole distance is 4 millimeters. Okay, the standard straw is 4 millimeters in diameter and 0.5 millimeter thick. So this distance right here is 0.5 millimeters. Okay, so that would mean that if this whole thing is 4 millimeters minus 0.5 would be 3.5 millimeters, and then minus 0.5 over here would be 3 millimeters. So this is 3 millimeters, so this would be 1.5 here and 1.5 here. It's hard to draw that small. Okay, so now we doubled both the thickness and the width of the standard straw. Okay, so if we double the width, that would make this 8 millimeters. And since I doubled the thickness, this is 0.5 millimeters, this would be 1 millimeter, and this would be 1 millimeter. So 8, so if this whole distance is 8, the diameter doubled to 8, then this would be 7, and this would be 6. So this distance here would be 3, and this distance here would be 3. So we have 1 plus 3 is 4, plus 3 is 7, plus 1 is 8. 1/2 plus 1.5 is 2, plus 1.5 is 3.5, plus 0.5 is 4. So 4 and 8, okay? Diameter doubled, thickness doubled. So there is our diagram. What is the cross-sectional parallel to the base area of the new straw? This one here. So the area of a shaded region, if you will, or of the annulus, this part here, this would be shaded. That would be the straw. That's my shaded region there, equals pi times big R squared minus little r squared. Substitute in my givens. So the area of the shaded region equals pi. Big R would be from here all the way to here, which is 4 squared, minus little r, which is the inside radius of 3. So that'd be 3 squared. Okay, so the area of the shaded region equals pi times 16 minus 9, which equals pi times 7, or 7 pi. So the area of the shaded region is 7 pi. Okay. It says round your answer to the nearest hundredth. So the area of the shade, whenever you see that, when it says to round, it wants a accurate or an approximation. We're not going to leave it in terms of pi. So I say 7 pi, enter, and hundredth is 3 decimal places. So 21.99, and that one would cancel out or drop off. So the area of the shaded region is 21.99 millimeters squared. Okay, so there's 2 ways to look at this too. I did the example where I was assuming that the diameter was the complete distance from one edge of the outside of the straw to the other edge. You could also, it did not say that the diameter of the interior was. And actually the teacher edition is showing the values for if we were thinking about the inside being 4. Okay, I would not think of it that way. A diameter is a diameter, and they're saying if they would say inside diameter, then that would have been a better worded question. But I'm going to leave this as this. You may have a different answer. If you were thinking that the straw was bigger because you were thinking of the inside being 4, and then the new one would become 8 plus these 2 would make this 10. So your answer would be 28.27 millimeters. 28.27 millimeters squared. So that would be if you were thinking of inside diameter being these values. I was thinking of the outside diameter. It did not say inside diameter, it just said diameter. So who knows? Anyway, it's all on how you see a problem. Part B, if the new straw is 10 centimeters long, let me get rid of this. If the new straw is 10 centimeters long, what is the maximum volume? Okay, so actually I didn't want to erase that. So if a cross section is the base area, so area equals base times height, and capital B means our base area, and in this case, it's the area of the shaded region of the annulus. So the area equals, well, we found our base area. I will do both of these just in case you got this answer. So you get 21.99 millimeters squared times the height, which is 10 centimeters. This is in millimeters. I need to change 10 centimeters to millimeters, and that is 100 millimeters. Okay, so my height is 100 millimeters. So the area of the straw would be the area of the cylinder is, what is the maximum volume of the milkshake that can be in the straw at one time? That one we would want the inside. Okay, so let's start this over. We don't want the value of the annulus. Okay, so we want the area inside of the circle. So area of a circle is pi r squared. Okay, we want to know how much volume is in the straw. All right, so area equals pi r squared. The area of this little circle, if this is 3, A standard straw is 4 millimeters in diameter. So again, they were thinking inside diameter, but they didn't say. So I'm going to do both. So area equals pi 3 squared. Or if you were thinking of the inside being this 4, then you'd say, let me move this over a little bit. Move that there, move that there, move that there. So then this could also be, that's an or, area equals pi 4 squared. Okay, so if you were thinking of this as being 4 millimeters in diameter from outside to outside, then the inside diameter would be 3. The area of that circle would be 9 pi. This one would be area equals 16 pi. So those are the two different ones I'm going to do. So the base area would be 9 pi. I'm thinking height, and I wrote capital H, 9 pi. And the height is 10 centimeters, which is 100 millimeters times 1. Oh, this is pi centimeters, by the way, or millimeters. So let me write that. 9 pi millimeters squared times 100 millimeters. And that's going to give me 900 pi millimeters cubed. And I have area here. I apologize. I don't know what I'm thinking. It's volume, volume, volume. All right, what is a volume? So volume equals 900 pi millimeters cubed, and it says round to the nearest hundredth. So they're saying put that in the calculator. Do not want pi value. So 900 pi equals 2827.43. If you were thinking of it as being the outside, then we're going to do this again. Volume equals this base area times this height. So it would be 16 pi millimeters cubed times 100 millimeters. So volume equals 1600 pi millimeters cubed. Put that in my calculator, 1600 second pi, enter, 5026. So volume equals 5026.55 cubic millimeters. Okay, page 3 brings us to part C. All right, so I brought over the two values that I got in the last problem. So if you were assuming that when they said 4 millimeters, again, let's go back. If you were assuming that 4 millimeter diameter was the outside diameter, then you would have a smaller value. But if you were thinking it was the inside diameter, these were the two values we got. And I'm going to round to the even millimeter, cubic millimeter. So it's 2827 cubic millimeters if you were assuming this was the outside diameter. And if it's the inside diameter, then it was 5027 millimeters cubed. And I brought those over here, and I might as well put mm cubed, mm cubed. So that was the volume if you had the outside diameter of 8 or 4 and the inside diameter of 4. Okay, so I'll do both ways. So a large milkshake is 32 fluid ounces, which is approximately 950 milliliters. If Corbin withdraws the full capacity of a straw 10 times a minute, what is the minimum amount of time that it will take him to drink the milkshake? Round your answer to the nearest minute. Okay, so the first thing I want to talk about is 950 milliliters when we have millimeters. So I don't know if you know this or not, but 1 millimeter equals 1 cubic millimeter. I'm sorry, 1 milliliter. Let me get this straight. 1 milliliter equals 1,000 millimeters cubed. Cubic millimeters, 1,000. What's wrong with me? I write 100. Okay, try this again. 1,000 millimeters cubed. So if I have 950 milliliters, then that would be 950,000 mm cubed, 950,000 cubic millimeters. Okay, so let's figure out how much he's going to do in a minute. So he's going to, here's how we do this. We're going to take both of these values. We're going to do different ones. Okay, so I'm going to take the amount of liquid milkshake in a full straw with the smaller straw. In other words, the one, if we were assuming that that was a 4 millimeter outside diameter. So we take 2,827 millimeters times 10 of those per minute. Okay, and that is going to equal 2,827 cubic millimeters per minute. And this is cubic, by the way. Cubic millimeters per minute. Okay, so time needed to finish 32 fluid ounces, or 950,000 cubic millimeters, would be 950,000 cubic millimeters divided by this 28,270 cubic millimeters per minute. Okay, so this is going to equal 950,000 divided by 28,270 equals 33. And it says round to the nearest minute. 33.6 would be an approximation of 34 minutes. Okay, because the millimeter, cubic millimeters cancel, we're left with the unit measurement of minute. Okay, that was for if we were thinking that that 4 millimeter diameter was the outside diameter. Now I'm going to do it for if you thought it was the inside diameter. So now we're going to use this value. It's the same setup. So instead we're going to say 5,027 millimeters cubed times 10 per minute equals 5,027 millimeters cubed per minute. Okay, so then we do this calculation. We take the 950,000 cubic millimeters divided by 5,027, 50,270 millimeters cubed per minute. And that's going to cancel the millimeters. We're just going to get minutes over here. And if I take that same 950,000 divided by 5,027, then I get 18.89, and they said round to the nearest minute. So I'd say that would be approximately 19 minutes. Okay, 34 minutes if you're thinking the smaller straw, 19 minutes if you are thinking the bigger straw. So it'll take them approximately 19 minutes to drink the milkshake at 10 straws full a minute, or 34 minutes with the bigger straw. All right, number 5. In the circle given, ED is the diameter. So let's mark this. I love marking these up with color. Highly recommend my students have colored pencils and to do the same. So there is the diameter ED, and I guess I could underline that here as well. Given the circle with the diameter ED, it is perpendicular to chord BC. So there is a right angle here. Okay, DF equals 8 centimeters. So from here to here is 8 cm. FE is 2. So this little piece here is 2 cm. Therefore, our diameter is 10. So ED equals 10 cm. I will write that there. Find AC, BC, measure of angle CAB. Okay? Well, if we have a diameter that intercepts a chord at a 90-degree angle, then it bisects the chord. So this BF is equal to CF. Okay. AB is a radius. So let's draw these all up. I'm going to mark everything I know. AB is a radius. AC is a radius. Since DF is 8 and FE is 20 and DE is a diameter, or not 22, 8 plus 2 is 10. Therefore, the radius is 5. So AC is 5. AB is 5. All right. And we have a right triangle now. So if this whole thing is 8 and this is 2, then the diameter is 10. Well, what does that tell us about DA? 8 plus 2 is 10. DA is a radius. That is also 5. So if this is a radius and this is 2, then the height of our right triangle is 3. So now I see that that is a 3, 4, 5 right triangle. So I'm just marking this up. Don't need to do the Pythagorean theorem if you remember your special right triangles or your 3, 4, 5 right triangle. Okay, so let's answer these questions now. AC equals 5 centimeters because it's a radius. BC equals 4 plus 4, which is 8 centimeters. Okay, and what else do we need? The measure of angle CAB equals, and here's C, here's A, here's B. So they want this whole radius right here. Okay, well, if this is a central angle, it's equal to its intercepted arc, but we don't know any arc measures. So without knowing any arc measures, I can't just say, well, if I knew this arc BC, then I would just divide it by 2 and I'd have the measure of that angle right there. But the measure of angle CAB, measure of angle CAF is congruent to the measure of angle BAF because these two triangles are congruent and they're right triangles. So let's just focus on 1/2 of it, which would be right here. So as you can see, I have a right triangle. Let me just draw it out. Okay, we have a right triangle and I want to flip it. Left to right, there we go. So now I'm just drawing this so that you can see this better. The base is 4, the height is 3, and the hypotenuse is 5. And we're talking about this angle up here. We want to know what that is. Well, opposite over hypotenuse, we can use sine of theta equals 4 over 5. So to find theta, we do the sine inverse of 4/5. So theta equals, go to my calculator, turn it on, clear. Always check to make sure you are in degrees. So I will move down to here and hit enter. And then I put my calculation in second sine for sine inverse, and 4 divided by 5 equals 53.13. Let's just round it to 2 places. So it's an approximation, and it's approximately 53.13 degrees. That's half of it. So that equals 2 times 53.13 degrees, or that would be 6, 2, 6, 10, 106.26 degrees. Okay, Does it say to find anything else? The arc length of angle CEB. So arc length is right here. Okay. So arc length arc length is the central angle divided by 360 times the circumference. Circumference is 2 pi r. And the radius is 5. So 10 pi. So if I go in my calculator and take this times 2 to get that 106.26 divided by 360 gives me 0.2951 times 10 pi. That gives me 9.2729. Okay, or 9.27 centimeters, rounding to 2 decimal places. All right, and now I want the area of sector CAB. How much area is that piece of pizza? So the area of a sector equals central angle 106.26 over 360 times area, which is pi r squared, which equals, so I'm going to do this again. So it's 106.26, and then I'm just going to put this all back in 02047. I like to be as accurate as I can. 02047 divided by 360, enter, times 25 pi, 5 squared pi, gives me 23.18 cubic centimeters. Okay, so there is all of that coming from one circle, just given the length of a diameter. Isn't that crazy? All right. Okay, so now it says, given a circle A with angle B, A, C, congruent to angle BAD. Find the following round to the nearest hundredth if necessary. I'm confuzzled. I believe that there might be a misprint here. There is no angle BAC. In order to have an angle BAC, a bangle tighter, in order to have an angle BAC, you would draw a line from B to A and down to C. Okay, unless this is what they meant, is congruent to the measure of angle BAD. Okay, anyway, I'm not sure what they mean, but let me see if I can come up with some stuff here to help you out in this problem that I think there might be a misprint in. Okay, so let's look at this angle here, angle CBD. It's 22.5 degrees, and it is inscribed, so it is 1/2 the intercepted arc. So this is 45 degrees. Okay, the radius is 12 yards. So this radius over here is 12 as well. Okay. So what else can we get from this diagram? If I extend a side, so I'm just going to mess around here because this problem's problematic. Okay, so if I line this up like so, just trying to get it pretty close here. If that were a diameter, then that whole thing would be 24. This would be 180 degrees. So I extended this out. So 180 degrees from this point here, and I'll call that, let's see, A, B, C, D, call that E right here. So CE plus CD is a semicircle, 180 degrees. 180 minus 45 is 135. So CE is 135 degrees. This arc right here would be 135 degrees, which would make this angle right here half, which is 67.5 degrees. I can't write that small. All right, so I'll just make it bigger, 67.5 degrees. Is that right? 7 7 is 14, 12, 30, 13, yeah, 67.5 degrees. All right. If I were to also draw another diameter and continue CA over here so that it reaches over here to another point, let's call it F just to stay in alphabetical order. All right, so this angle is 67.5 degrees. This angle is 45 degrees, and this angle is 45 degrees because they're vertical. And 67.5 and 67.5 is 135 degrees. And this is 45 degrees, and this is 45 degrees. I made a mistake. This is not half, it's equal. It's a central angle. That made no sense. This is 135 degrees. Okay, so this is 135. 135 and 135 is 270 plus 90 is 360. Okay, that makes sense. So this section here, this arc is 135 degrees as well. Okay, so this whole thing is 45 degrees. Okay, so the measure of arc CD is 45 degrees. I agree there. The measure of arc C over to B all the way around to D is the rest of the circle. So that would be 360 degrees minus 45 degrees, which equals 315 degrees. All right, page 4. I think we're on page 4. Yes, page 4. All right, continuing on with this. The measure of arc B, C, D is here. Well, this whole thing is 45 degrees. And this, since this is 45 and that's 45 and that's 135, that's 135, this has to be the midpoint because it's centered around this intercepted arc. This should be 22.5 degrees, and this is 22.5 degrees. So we're counting this BE. So the measure of arc BCD, so I'm going to write this out in words first, equals the measure of arc BE plus the measure of arc EC plus the measure of arc CD. So notice that this first letter is B and this last letter is D, and C is in between. There you go, B, C, D. E's in there as well, but we only need 3 letters to name a major arc. So now BE is 22.5 plus EC 135 plus CD 45 degrees equals, and that comes out to be 202.5 degrees when you add those up. Okay, now arc length of CD equals, well, where's CD? It's right here, formed by the central angle CAD, which is 45 degrees. So arc length is the central angle divided by 360 times 2 pi r. Okay, so that's going to be 45 divided by 360 times 2 pi, and the radius is what is the radius? Oh, it's given right there, 12 yards. All right, times 12. Ooh, scared me for a minute. So 45 goes into 360 8 times. So that's going to be 1/8 times 24 pi. So 1/8 of 24 is 3 pi. And if you don't want to leave it in pi units, then you go to the calculator and you type in 3 pi and you get 9.42. So it's approximately 9.42 unit of measure is yards. So there's the answer to D. Arc length CBD is this whole thing out here, which is 360 minus 45 degrees, which is 315 degrees. So that's the central angle 315. So let me change color. So that's going to equal 315 divided by 360 times this same 24 pi, which is going to equal, and let's just do it this way, 315 divided by 360, and hit math, enter, enter, and it gives me my reduced fraction of 7/8 times 24 pi. Well, 24 divided by 8 is 3 times 7 is 21 pi. So the approximation will be 21 pi. Well, the exact is 21 pi. The approximation will be 65.97. 65.97 yards. Okay, so that's the arc length all the way around the other way. All right. F, arc length BCD. B, all the way over to C, over to D. So that's 22.5 plus 135 plus 45. First thing I want to do is find my central angle. I'll do that right here. And it was 22.5 plus, so what is it, BCD? BCD, oh, it's right here. It's 202 degrees and a half, 202.5 degrees. So we've already found the information needed for the equation. So that's going to equal the central angle of 202.5 divided by 360 times 24 pi. And that's going to equal 202.5 divided by 360, enter, times 24 second pi, enter, and I get 42.41. And its approximation, approximately 42.41 yards. Okay, and now the area of the sector CAD. So where is sector CAD? Let me do that in orange. Here's C, here's A, here's D. So it would be this area, or this slice of pizza, if you will, or pie. Okay, right here. So it's going to be this along with that piece there, central angle of 45 degrees. So area of a sector is the central angle divided by 360 times the area of a circle, which is pi r squared. Okay, so I'm just going to put this in my calculator. So 45 divided by 360 is 1/8 times 12 squared, which is 144 pi. And the area will be 56.55. It's an approximation, 56.55 yards squared. Okay, number 7, given circle A, round to the nearest, find the following, round to the nearest hundredth, 2 decimal places, if necessary, circumference of circle A. Okay, well, circumference equals 2 pi r. Okay. I know an arc length. That's a really poor place to put that. That should be in here. That makes it look like this big angle is 45 degrees, and obviously it's not. So we have a 45 degree central angle. So this is a 45 degree arc that is 12 yards long. Circumference equals 2 pi r. Okay. So let's think about this. Okay, so I was just trying to think if I could use radians to do this, but they didn't give me the length of the radius, so I don't know how much of that is not a radian there. But I do know 45 degrees is a percentage of a circle. So 45 is a portion of a circle. It's an eighth of a circle. So if this is 1/8, then I take 12 yards and I multiply it by 8. So my circumference is 96 yards. Okay. So my circumference is 96 yards. Not really much of a calculation here. I guess if I showed my work, I'm not going to use the circumference equation 2 pi r because I don't know the radius. But if this is 12 yards and this is 45 degrees, 45 times 8 is 360. So there would be 8 of these 12 yards that would make a full circle. So it would be, since that is 1/8, it'd be 8 times 12 yards, which equals 96 yards. Okay. Okay, page 5. I copied the circle over, so it's the same circle from the prior page. Now it's asking for the radius of circle A. So now we're going to find what that radius is. So if I know the circumference, C equals 2 pi r, and I know the circumference from the last page is 96 yards, then I always put 96 over here equals 2 pi r. And in order to find my radius, I just divide both sides by 2 pi. How cool is that? So my radius is going to equal 96 divided by 2 pi. It's an approximation. I keep forgetting that. And it is an approximation. So r is approximately 96 divided by 2 pi. 96 divided by 2. And whenever you do this, you have to put it in parentheses, or it will say 96 divided by 2 times pi. It does order of operation. So I want to make sure that 2 pi is in parentheses or the answer will not be correct. I'll show you again in a second. So if I did 96 divided by 2 pi without parentheses, did I get 15? I did not. I got 150. So it took 96 divided by 2, which is 48, times 3.14, and it got that. Okay, that's not correct. 96 divided by the quantity 2 pi gives me 15.28. 15.28 yards. Okay, so just be careful with your calculator. That's a common error. And now area of a sector CAD. Well, area of a sector equals the central angle divided by the total circle 360 and times pi r, which is 15.28 squared, pi r squared. So it's going to be, just using the calculator, 45 divide 360, and I get 1/8 times 15.28 squared pi. I get 91.69. Okay, so that's an approximation, 91.69 yards. 91.69 yards. Okay. Number 8. Given a circle A, okay, centered at A, find the following, round to the nearest hundredth if necessary, the measure of angle CAD. Okay, we have a radius of 12 that we know. We have an angle here we don't know. We have an arc length of 10. So we need to use the arc length. So arc length equals the central angle divided by 360 times 2 pi r, right? The portion of the radius, portion of the circumference is arc length. And so my arc length in this case is 10. So that's why I always say write a formula, substituting the givens. Arc length is 10 equals some angle that we're trying to find over 360 times 2 pi 12. Okay, so the only thing we don't know is that angle, all right? So then 10 equals theta over 360 times 24 pi. So I'm going to divide both sides by 24 pi. And that will give me theta over 360 equals 10 divided by 24 pi. And let's just do that. 10 divided by 24 pi. And that's not right. Remember what I said last time? 10 divided by parentheses 24 pi in parentheses. Enter 0.1326. So 132629.1326. And then I multiply by 360 on both sides. And that will give me my theta. These cancel, and I get theta equals that times 360. It's already in my calculator. If I just hit the times, it'll say answer times 360, and that will give me my 47.75 degree angle. And it's an approximation, 47.75 degrees. Okay. Okay, let me change colors because I kind of came into this. Let's do this. Area of sector CD. So I want the area. It's this piece of pizza, if you will, or slice of pie. What is the area of this? Well, area of a sector equals central angle over 360 times pi r squared. Okay. So the area equals my angle measure, 47.75 degrees over 360 degrees times 12 squared pi. R squared, 12. So I'll just do this in my calculator. So the area is going to equal this angle divided by 360 times 144 pi. And that gives me 60. So the area equals 60 units squared. Alrighty. Okay, page 6. Just keeps going. Number 9. Find the area of the shaded region. I guess this really bad shading here. Round to the nearest hundredth. Well, for starters, it is a rectangle. So the area of a rectangle equals, base times height. Length times width, if you will. Well, this is a radius of a circle, so therefore this is a radius, so this is 5. This is a radius of a circle, which is 5. This is also a radius, so that's 5. All right. So the area of the rectangle equals base 5 times height. Well, this is 10 and this is 5, so that's 15. So that equals 15 times 5, which is 75. Okay, that's the area of the whole rectangle. Obviously, we have the shaded region here. What we want to do is subtract this region and this region from the rectangle to get the shaded. So it's going to be 75 minus these two areas. Okay. So actually, let me make that red. And let's make this all a different color. How about blue? Okay, so we got the area of the whole rectangle, which is blue. This is all of this minus those two reds will give me that. Okay, so I'm just doing it with color. So what is the area of this? Well, that's a right angle, so that's 90 degrees. So that's 90. So I'm going to do the area of the shaded region. Okay, which would be the area of the shaded, or not area of the shaded region, but the area of the sector. Equals, the area of a shaded region is the angle measure over 360 times pi r squared, and r is 5, so just to save time, 5 squared is 25, so that's 90 over 360, which is a quarter. All right, so I'm going to put that in my calculator. So it's going to be 90 divided by 360, which is 1/4. I could have just done that. Enter, and then times 25 pi. Okay, so it's 19.63. That's each of those. So it's 19.63 minus 19.63, if you will. I'm subtracting two of them, and that will give me my answer. So now if I take 75 minus the answer, hopefully this works. I've never done this before. That gives me 35.73. It does work. How cool is that? 35.73 units squared. Okay. All right. Number 10. Many large cities are building or have built mega Ferris wheels. One is 600 feet in diameter, has 48 cars each, seating up to 20 people. Each time the Ferris wheel turns theta degrees, a car is in a position to load. How far does the car move with each rotation of theta degrees round to the nearest whole number? All right, so what we have here, let's draw a picture. There's my center of my circle. There's my Ferris wheel. And it has 48 cars each. So what does that mean? I'm not going to draw every single car, but I'm just going to show you that if we draw a radius out like so, and another radius out like so, there would be 48 of these all the way around. So each section in between we assume would be equal. Okay. So it would be 360 divided by 48. So 360 divided by 48 will give me how many degrees in between each. So this angle measure here would be 7.5 degrees. Okay. This says it's 600 feet in diameter. So let me draw a diameter. I'll do it in green. Going through the center. Let me make that center a little bit more pronounced. So there's the center. This is 7.5 degrees. The diameter is 600 feet. So therefore the radius is 300 feet. Okay. 48 cars being 7.5 degrees apart. Each seating up to 20 people. That confuses me. If there's 48 cars and it seats 20 people per car, that's a pretty big Ferris wheel. Anyway, each time the Ferris wheel turns theta degrees, which is 7.5 degrees, a car is in position to load. How far does a car move with each rotation? So what they're asking for is the arc length. So arc length equals theta over 360 times 2 pi r. Okay, so the arc length is going to equal 7.5 divided by 360 times 600 pi. That gives me 39.27. So it's an approximation of 39.27 feet. Okay, whenever I get an answer, I always go back and look at the last thing. It says round to the nearest whole number. All right, 39 feet. What is the value of theta in degrees? Well, it's 7.5 degrees. We already calculated that to find the other. All right. Another way we could have done it, though, is a full rotation of a circle is 2 pi. So if I took 2 pi and divided it by 48, that will equal, or I multiply it, that is radians. So I multiply it by 180 divided by pi. So this will cancel that. And that would become 1, and that would become 24. So 180 divided by 24. Did I do that right? Should be 7.5. Let's check. 180 divide 24, enter. Booyah, 7.5 degrees. So there's another way to do it, okay? So I just calculated 360 divided by 48 and found the angle measure, but we could have just taken 2 pi divided by 48 and multiplied it by 180 over pi to convert from radians to degrees. Okay, there's so many pages I lose track. 7, holy cow, page 7. Triangle ABC is an equilateral triangle with edge lengths 20 centimeters. Stop right there. If it's an equilateral triangle, it's also equiangular. So that's 60 degrees, that's 60 degrees, that's 60 degrees. Okay. If the whole side is 20, then this is 10. This is 10. This is 10. 10. 10. And 10. Okay. BF, BE, AE, AD, CD, CF are all 10. And they're saying DE and F are midpoints. That's why I cut that in half, 20, 10, and 10. The vertices of the triangle are the centers of a circle. So think about that. If I get a circle centered at B and bring it out, see how that lines up right there? That's what they're doing. They took circles like this. Okay, so that is, let's put that back. Oh, I'm going the wrong way. Redo, redo. Okay, so what do we have here? We have a shaded region sector. This is an arc. Okay, so I'm going to leave this circle here, and I'm also going to bring in a triangle so that we can discuss this in different formats more precisely. What is this doing? Can you please let me drag you? Thank you. All right, so here we go. Area of sector with center A. Well, they're just making it difficult. They're all the same. Let's just put that there. So they want to know what the area of this is. Well, the area of a sector equals central angle 60 degrees divided by 360 times pi radius 10 squared. So if I put that in my calculator, well, 60, this reduces first, and that would become 1/6 times 100 pi. Okay, so if I do that, then it would be 100 divided by 6 times pi. And I get 52.35, 52.359, round to the nearest hundredth. 52.359, the 9 will make that a 6, 52.36. Approximately 52.36 centimeters squared. Okay, that was pretty simple, yes, I hope. And then area of triangle ABC. Well, if this is A and this is B and this is C, And we know that this is 60 degrees and this is 60 degrees because the side lengths are all congruent. Hopefully you remember that if you drop a perpendicular, this is actually the proof to find a 30, 60, 90 triangle, because this is now a right angle here. And I bisected this angle up here. The whole thing was 60, so this is now 30 degrees. So we have a 30, 60, 90 triangle. These lengths are 20, right? 20 centimeters. So if that's 20, this half is 10. And so this is 2x, this is x root 3. So the height is 10 square root 3. If you know these triangles, it makes your life so much easier. So now the area of the triangle equals 1/2 base times height. The area of the triangle equals 1/2. The base is this whole thing, which is 10 and 10 are 20, times the height, which is 10 square root 3. So the area is going to equal 1/2 of 20 is 10. 10 times 10 is 100 square root 3. So the area is approximately 100 square root 3 equals 173.21. 173.21 centimeters squared. Okay, so now we're looking for the area of the shaded region here. So if I find the area of one sector, which we did right here, part A, and there's 3 of them, then the area of the shaded region is going to equal the area of the triangle minus the area of the sector minus the area of the sector minus the area of the sector. So it's this, this, and this taken away from the whole thing. So the area of the shaded region I'll put, and that should be there as well. Area, that's a triangle, by the way, pretty lame one. Let's fix that. Still pretty bad, but anyway, you get the idea. Area of the shaded region equals the area of the triangle 173.21 minus, and instead of writing this 3 times, I'll say minus 3 times what we got for up here, which was 52.36. So that is going to become this minus 3 times 52.36, and that will give me 16.13. And that's an approximation. 16.13 centimeters squared. And I suppose I could do this. All right, now what's the perimeter of the shaded region? So what's the arc length is what they're asking. We haven't found the arc length yet. So arc length, we need to find the arc length, which is from here to here, and then multiply it by 3 because they're all the same. So arc length equals central angle over 360 times 2 times pi times the radius. And there you have it. This is going to be 1/6. So this simplifies. 10 times 2 is 20. And 60 divided by 360 divided, it simplifies to 1/6. So it would be 20 times 1 or just 20 over 6 pi. Or 10 over 3 pi. If you want to reduce it, doesn't matter. 20 divided by 6, enter, times our pi, and that will give us 10.47, an approximation of 10.47 centimeters. That is just 1. Multiply that by 3, and we get, let's just do it here, times 3. Might as well save time. 31.42. Okay. So that comes out to be approximately 31.42 centimeters, because perimeter is side plus side plus side. So there we go. Okay, page 8 brings us to number 12. Are you ready for a challenge? Because if you aren't, then you're not ready for 12. 12 is challenging. Let's take a look at it. Don't be afraid. Let's just dive in and do it. In the figure shown, AC equals BF. So the first thing I'm going to do is just label everything up. I will use blue here, and let's make it thinner. So here is AC, here is B, here is F. Okay, just give me a second to fix that. I dragged a little, there we go. AC is equal to BF, and they are both 5 centimeters. I am not going to put the unit of measurement in there. It's too cluttered. That's 5, that's 5. Okay, GH is 2. So this section here, GH, is 2. Let me do that in red or purple or something else. Purple. Okay, this is a length of 2. Well, look at this. If this is 5 and it is a radius, then that is 5. Well, if GH is 5, then AG is 5 minus 2, or 3. Okay, so I'll put that back, and I will do that in green. So AG is here, and this is going to be equal. Okay, and they're both going to be length 3. Okay, so there you have it. And since this is a radius 5, then if I do the same thing again here, this is a radius of 5. All right, let me just shorten it a little bit. And if I move it over to here, then that's also 5. And that's why I'm doing this, because this is a rectangle and it's asking us to find an area. Okay, so I'm just labeling all my givens here. So obviously EF is going to be 5, and D is going to be 5, plus 3, which is 8, plus 2, which is 10, plus 3, 13, plus 5, which is 18. So the whole side DE is 18. So there we go. Now they say the measure of HAI, so we need to draw that. I'll use red, and nice and thin. Red. That's this angle here. That angle right there, HAI, is 30 degrees. I can draw that small. So I'll just put 30 degrees with an arrow. Okay, this angle here, 30 degrees. Find the area inside the rectangle, but outside of the circles, round to the nearest hundredth. So where do they mean? Well, let's just shade this real quick. Let me pick a color that we're not going to use. How about this light blue? So we're talking about this area here. This might not be a good color to choose. Probably can't see it very well. So it's this area here, along with this area up here, and this area over here. Oops. Go outside that line. And right here, this region in here. I guess I could just do that in black. So let's change that. So this and this. Let me not waste your time. Okay, so that's what we're trying to find, that black shaded region here plus here plus here. All right, so how are we going to do that? Well, when you have an odd shape, use a shape that you're familiar with and subtract it. So we have a rectangle. So let's first find the area of the rectangle. And that equals base times height. And that is going to equal 18 times 5. And that is going to equal 90 centimeters squared. So this whole area here is 90. So I know my answer is less than 90. Okay. So then I want to take semicircles. But the problem with that is if I take half of a circle and find the area of half the circle and the area of half the circle, which are equal, and double it, I'm counting this area twice. And I can't do that because it'll be wrong. So here's what we're going to do. We are going to draw a height. Let's make it thin right here. And that is going to cut that section in half. Okay, so then I will back this up to here. So now we have a right triangle with a 30-degree angle here and a 60-degree angle there. It's a 30, 60, 90 triangle. So now I'm going to redraw that off to the side so we can blow it up and figure out what's going on here. Okay, so here's our right triangle. So that's just this triangle blown up here. Okay, and I know that this height or this distance is 5 because it's a radius. AI is a radius. A to here is 3, and that's a halfway. That's a midpoint right here. So that's 2, so that's 1. So this is a distance of 4. So therefore, this has to be a height of 3. It's a 3, 4, 5 right triangle. Okay. And we knew this was 30 degrees. So if I did this, if I said, well, if that's 30 degrees, then this opposite side here would be the hypotenuse times the sine of 30. So it'd be 5 sine 30. So let's check that. 5 sine 30. Enter. And I got 2.5. What do you think about this? Okay, I'm not sure they set this problem up correctly because the 30-degree angle will not work here because with my calculation here, this has to be 5. The hypotenuse has to be 5 because it's a radius of the circle. That is for sure. And the way they split this out, they told us GH is 2. And if this is a bisector, you can see that the two circles from G to H, if we drew arcs from G to H like that, or AH and BG, that would be a bisector right there. That is the classic construction for a bisector. So we are cutting that in half. And we were told this was 2. So this piece would be 1 and this piece would be 1. So 3 plus 1 plus 1 or 2 is 5. And that's a radius. This has to be 5, 3, 2. And with that setup, this length of this base is that 3 to here plus 1 more to here, which is a total of 4. Well, that's a 3, 4, 5 special right triangle, but it can't have a 30-degree angle. So they're telling us this angle measures 30 degrees, but it's hogwash. Okay, that can't happen. Ay caramba. Okay, so anyway, I'm going with this. And this 30 degrees here is going to cause a problem because what we have to do is find the area of this triangle and the area of this sector, because we have a sector here with a 30-degree central angle. So I'm going to take the area of the sector, and instead of writing sector, I'm going to draw one. How's that? Area of the sector is going to equal the central angle divided by 360 times 2 pi r, and pi r squared area, pi r squared, and r is 5, so that'd be 25 pi. Okay, central angle times pi r squared. This will reduce. This will become 1/12. So that's going to become 25 pi over 12. And I put that in my calculator. 25 pi divided by 12 equals 6.55. That's approximation. 6.55 centimeters squared. Okay. Well, if that's 6.55 centimeters squared, and that's the whole sector, and the area of this triangle would be 1/2 base times height. Here's my base, here's my height. 1/2 of 12 is 6. So if I subtract the area of my triangle, which is 6, then I'm going to get 0.55 centimeters squared for this region right here. Okay, that is 0.55. And there's another one over here. So if I multiply that by 2, that would come out to be 1.1 centimeters squared for this whole region right here. Okay, so I'm going to subtract that. So now we're going to take the rectangle, which is here, subtract this, and then subtract, actually, here's what we'll do. We'll find the area of a semicircle. I'll do that in blue. So the area of a semicircle equals 1/2 pi r squared. So that's going to equal 1/2 25 pi, or 12.5 pi. So that's going to be an approximation. So the area of one of the semicircles, or actually I could just find the area of the circle, couldn't I? Because there's 2 semicircles, but we're counting this twice, so we'll have to subtract that. So let me just do that. Okay, if you did that, that's fine. We'll just have to do it, double it. But the area of a circle equals pi r squared, and that would be pi times the radius 5 squared, which equals 25 pi, which is an approximation of 25 pi is 78.54 centimeters squared. So that's one whole circle, but I'm counting this piece twice. So I'd have to take 78.54 and subtract 1.1 from that, which would be 77.44 centimeters squared. So that would be the area of these 2 semicircles without counting that twice. So then the area of the rectangle was 90 centimeters squared. So when we subtract that, we're going to get, okay, whoops, that's 9, and make that a 10. That would be a 6, a 5, a 2, a 1, 12.5 centimeters squared. Okay. Okay, so if you're using the key to the teacher's manual or whatever, the teacher's edition, they came out with 17.03 centimeters squared by using the sine of 5 sine 30 and 5 cosine 30 in this right triangle here, but that doesn't work with these lengths. So anyway. Okay, I can't let this go. So if you are a teacher and you want to use this problem, I was just trying to figure out what was going on here. This 30 degrees does not work because of this special right triangle. So I calculated it to be, all I did was said, well, what's the sine of 3/5? Sine of 30 equals 3/5. So the sine inverse of 3/5 is 36.87 degrees. So if you're going to call HAI anything, it has to be 36.87 approximately. 36.87 degrees, because if that is 36.87 degrees and I take the sine of that 36.89 degrees, I get that 3/5. sine of 36.87 equals 3/5. Okay. Cosine of 36.87 is 0.8, which is 4/5. So in the teacher edition, here's what it's showing. It is showing 5 sine 30 right here. But if I change that to 36.87 and make this 5 cosine 36.87 and put it in my calculator, 5 sine 36.87, I get pretty close to 3. And if I do 5 cosine 36.87, I get pretty close to 4. And these were 3 and 4. Okay, so I would fix that. If when I do it in class, I will change that. I'll cross it out and tell them to put 36.87 degrees in their student edition. All right, number 13. This is a picture of a piece of a mosaic tile. If the radius of each small circle is 1 inch, find the area of the red section, the white section, and the blue section, round to the nearest hundredth. Okay, so number 13, on this one, I just drew this triangle here, okay? And we're gonna do the blue one first. I'll work on the blue one first. So this is a circle with a radius of 1, like they said. So this is 1 inch, this is 1 inch, and I created this right triangle 1 by 1. Well, this is a 45, 45, 90, so it's x, x, x root 2. So this side is definitely the square root of 2. And how about I just put that as the same color as all the other measurements like that? Okay, so we have the square root of 2 for the hypotenuse. Is that necessary? Do we need that? Maybe not. All right, so anyhow, here is the triangle. What we're trying to do is find the area of the sector and then subtract the area of the triangle, and that will give us half of the blue shaded region because the triangle is bisecting that blue region. So area, what is my pen doing? Area of sector minus area of triangle equals 1/2 the blue area. Okay? It's the outside, and then we just double it. So the area of the sector is area of a sector equals central angle divided by 360 times pi r squared, which is just simply pi, because 1 squared is 1. 90 divided by 360 is 9/36. 3 goes into 9 3 times. 3/12, 9 times 4 is 36, so it's pi over 4. So the area of the slice of pi, if you will, is pi over 4. The area of the triangle is 1/2. 1/2 base times height. So it's going to be the area of the sector minus the area of the triangle, and that is going to equal this outside piece. Okay, so if you will, let me switch to blue. In the blown up section here, there is a little bit of a circle here, and we are finding this area, but it's going to be equal to this one. So the area of this whole piece of pi, if you will, minus the triangle will give us the outside half of the blue shaded region. So we just double it when we're done. So pi over 4 minus 1/2 is what we came up with. So pi divided by 4, enter, minus 0.5, enter, and that is 0.285398. But there's another one on the other side because that's only half of it. So I'm going to multiply that by 2, and that's going to give me 1 blue one, but there are 4 of them. So I got 0.5707. Okay, but there's 4 of them. So I multiply that by 4 and I get 2.2832. And it says round to the 100th, 2.28 inches squared. Okay. Okay, so I copied over 2 circles here because I want to discuss what was going to happen here. So this 0.5707 is one of these blue regions. So that would equal this right here. And the radius of these circles is 1. So area equals pi r squared, which is 1. So the area of one of these circles is simply pi. So this is an area of pi, and this is an area of pi. And then we want to subtract 0.5707. Okay, and so what I'm working on right now is the area of the white. So we have pi and pi and pi and pi. So the area of the white equals 4 pi, but then we have to subtract 1, 2, 3, 4 of these, which is that 2.28. So that's going to equal 4 pi minus 2.28, 3185307. I'm just copying it from up here to be more accurate. And I got 10.28. 10.28 centimeters squared. Okay. All righty. So there's the white. So the area of the red, okay, I get it. The area of the red equals area total minus area of the white. So the area of this circle now, if that's 1 and that's 1, that has a radius of 2. So the area of the triangle, or the circle, I mean, the big circle is pi r squared minus, and the area of the white, which was 10.28 cm squared, area of the white here, I brought this down here. The area of this big circle is pi r squared. And the radius is 2 because this piece was 1. The radius of the little circle is 1. So the radius of the big circle is 2. So that would be 4 pi minus 10.28. So if I go into my calculator and go 4 pi minus, and I've already got it up here. So I'll put just second answer for that 10.2831, blah, blah, blah. I get the area of the red to be 2.28 inches squared. And if you notice, the area of the reds equal the area of the 4 blue. So these areas are equal to these areas. That was interesting. Okay. Okay, page 9. That lesson had 8 pages. Okay, I'm okay. Page 9 brings us to the end of lesson 10. Go do your problem set.